Hello guys, I frequently use these kinds of batteries, type AAA, for all sorts of devices, and quite often I had the problem that I don't know if those batteries are still fully charged or at least usable for some time. And of course there are battery testers around you can buy. But, well, I chose not to buy one, but instead use a little flashlight for one such battery and shine it against the wall to see how bright it shines. If it doesn't shine bright, then I suspect that the battery won't be usable anymore. Unfortunately though, my eyes, or anyone's eyes, are not so well suited to measure the brightness of the light. And so I wondered if there is a possibility to automatize this with some Arduino stuff. And yes, it looks like, and so I came up with this tool, which is later explained in the video. Also, you will see how I made it. The parts that are needed is this piece of wood, some piece of wood, which you can drill into. Then your favorite Arduino board, preferably a small one, like this Arduino Nano clone. And this one already has an USB port attached to it, so you can easily power it. Then you will need, of course, which is the most important part of the project, a photoresistor. This one is a KY018, which outputs values between 1 and 1024. Depending on the intensity of the light you shine on this resistor. It has a signal pin, plus and minus pins, so very easy to install. And you will need some sort of display. In this case, I've used this one, like most of the time, for simple projects. GMT 130 V1.0 IPS 240 times 240 pixels, which has no CS pin. That's the reason why this display is so cheap, but it's very useful for a simple project like this. Then you will need, of course, as shown before, this a little flashlight and that's important, just one battery, otherwise you will not be able to tell which battery is bad and which is good. So just one battery inside, and this one is for AAA. It has a diameter of 40 mm. Later in the video you will see that I am using a driller which only has 30 mm. That's due to the fact that I didn't have one with 40 mm, so I had to improvise a little bit, but you will see that in the video. And of course you will need the batteries to test. And yes, I think that's all you need. Oh, you'll need some, yes, you will need some hot snot to glue everything together, but that you will see also in the video. Okay, see you later. This is the configuration of the Arduino Nano, the TFT display and the photoresistor KY018. The TFT display is connected via D13 to SCK, ground is connected to ground, VCC is connected to 5 volts, SDA is connected to D11, D9 goes to DC, D8 goes to RES, and A0 goes to the signal pin of the photoresistor, and VCC and ground go to the respective pins on the Nano, like the TFT display. So I'm going to glue this together now. Oh, I should put this there. Something like so. This sticks this, and the photoresistor gets downstairs. Which is there. Alright, now I'm going to do this a little bit into the hole. Should suffice. Now this quickly inside. Alright. Something on top. Cables should point to the side so it doesn't lift the whole thing up. Wait a little bit until it's cooled down. Maybe a little bit here as well. There. Very sticky. Something like so. This should hold together. And maybe the cable's a little bit still. Just like that. Got to be a little patient now until this is cooled down. Give it a little blow. When this glue doesn't look transparent anymore, it should be cool. No, that was too early. Right, seems good. Doesn't look very nice at the moment. Clean it up a little bit. Alright. Now it should be ready for use. There's the photoresistor inside. It doesn't really matter how it's put exactly inside. The values will be constant as long as it doesn't move. And it won't move in this position anyway, so we'll just have to adjust the values a little bit to see which values are right to use. Alright. Perhaps let's put a few bumpers on the side to protect the PCB. I hope this is gonna work. You could also put screws inside or something. But this should also do the job. I just noticed the glue is used up. Okay, that looks a little bit stupid, but should work. Alright, now the whole apparatus is ready for use. I've just added a counterweight, so the whole thing remains standing on the ground, just in case you wonder what that is. And I've already uploaded a small sketch, a very simple one, which only reads out the values of the photoresistor, which is placed down there. I hope you can see it. There it is. And let's plug in some power via USB into the Nano. And there you can see the values of the photoresistor. In its original configuration, the values show higher values if there is less light, and low values if there is a lot of light. So you have to subtract the actual values from 1024 to get inverse values. So high values correspond to a high readout of the photoresistor. If I turn this to the light, you can see, or not, well, the values will increase. I can also use, of course, this little lamp. There we go. That's almost the highest values. And you already see when the values are very high, they appear in green, red if they are very low. So this makes sense because it is meant as a battery tester, and the test is conducted via putting a battery, in this case an AAA battery, into the lamp and put it inside the hole. Now the value shows almost 0, which indicates that there's no light getting into the hole. And if I switch on the lamp, the values are getting green and yellow. Green shows that the battery is okay. Yellow shows that the battery should be removed. A couple of hours ago the values were always green. It seems that the battery has suffered a little bit. I don't know. You can of course adjust the colors according to your needs. The values will not always be the same for every setup. You have to experiment a little bit before you can make sense of them and say green corresponds to full battery, yellow should be replaced, red it's defective. But I think this battery can still be used. I've got another one which is definitely low in power, which I will put in now. You can see that this lamp is quite bright still, but I really think it is. Contacts are not very well. That's the reason why it wasn't so bright. I hadn't completely put on the cap, so now it should be completely green. Perhaps not. I don't know. I don't know. It's a very cheap light, so. Okay, let's put inside the bad battery, which is this one. You can already see it in the camera that it's not very bright. It's hard to tell. Well, with my eye I can clearly see that it's not as bright as the other one. But if I put it into the apparatus, that's more reliable than my eye. And the whole reason why I built it, it shows red values, which indicates a bad battery. Now, if this battery was completely out of order, the values would drop like this, but there's absolutely no light. But you want to know if the battery can still be used or not, and this one shouldn't be used anymore, because the values are, in this case, below 1000, and in the sketch I indicated that values below, was it 1005 or something like that, would be corresponding to a bad battery. Now, just for comparison, to put on the other battery, it's the bad one, and the good one, the almost good one. Right, there we go, the green values. Well, it's jumping a little bit, I don't know why. fluctuations. I think I've even put the yellow values at starting at 1014. Maybe that was a little bit high. I should really put few something like I said, 1005 as a starting point for that. Okay, now that's it. The sketch you can find in the description, and you can adjust it, as I said, to your needs. Maybe you use a different photoresistor, or the distances are different here than here, and you might also use a different lamp or for different batteries, so you will have to adjust the values accordingly. Okay.